A single meteorite wiped out every dinosaur on Earth in an instant, leaving not even a shadow behind. All that remained was a crater so massive it defies imagination. That place is Mexico's Yucatan Peninsula. Buried beneath it lies a supersized impact crater called Chicxulub. You might wonder, with a crater this big, where's the meteorite that hit Earth? Weirdly, no one has ever seen any of its remains. Yeah, it's that wild. A space rock that likely ended the dinosaur era just vanished into thin air. No one has ever found its main body. So where did something this important go? Some guess it completely vaporized and exploded on impact with immense force. Most fragments turned into gas or dust and scattered through the atmosphere. But others believe it might still be hidden somewhere on Earth. Now, scientists have finally found possible clues, but getting close to it? Extremely difficult. Let's go back 66 million years. A massive asteroid crashed into Earth, marking the end of the Cretaceous. It struck what is now northern Central America, Mexico. The impact triggered global heat waves, followed by years of brutal winter. The entire planet plunged into total chaos. The aftermath was devastating. Over 60% of all life went extinct. Not just T-Rex and Triceratops on land, but pterosaurs in the sky and mosasaurs in the sea. All gone, practically overnight. This event didn't just end the dinosaur age. It indirectly paved the way for mammals to rise, including humans like you and me, finally taking the stage. Recently, scientists finally pinpointed the likely origin of that infamous meteorite and its final resting place. This wasn't some random rock drifting near Earth. It likely came from beyond Jupiter's orbit, then barreled straight toward our planet. We'll get to that later. First, let's look at the details of that cataclysmic impact. When the meteorite hit, rocks deep in the crust were blasted up to 15 miles into the sky. The impact also formed mountain ranges taller than the Himalayas, rising around the crater's rim. The extinction-causing meteorite was about 6 to 9 miles in diameter, hitting Earth at nearly 12 miles per second. The impact angle was around 60 degrees, the perfect angle to vaporize and eject the most rock into the atmosphere. This sent massive amounts of sulfur and dust skyward, blocking sunlight. Earth endured a 15-year impact winter. Dinosaurs had ruled the planet for nearly 200 million years, yet couldn't survive this disaster. Some scientists argue the asteroid was just the final straw. Dinosaurs were already on the brink. Either way, most dinosaurs ultimately went extinct. The few that survived may have evolved into modern birds. To piece this together, scientists spent decades. In the 1970s, researchers at a Mexican oil company first discovered the giant crater. Scientists later realized its link to the Cretaceous mass extinction. One key clue came from ancient fish fossils found in the area. Think about it. The moment the meteorite hit, the massive shock wave blasted deep crustal rocks skyward. Some even turned into glass-like, twisted tektites. These tiny spiral ejecta particles formed when molten material cooled rapidly mid-flight. Even wilder, some of these ejecta got lodged in the gills of fish at the time. Later, while studying those fish fossils, scientists uncovered a stunning clue. By analyzing growth lines in the bones, like tree rings, they determined the catastrophe struck in the northern hemisphere's spring. The impact left traces far beyond geological deformation. For decades, scientists have studied the impact site, hoping chemical signatures would reveal more truths. Fragments of the meteorite now lie buried beneath the Yucatan Peninsula, under thick layers of rock and sediment. So they turned to chemical signatures in the rocks, especially in layers from the end of the Cretaceous. They ultimately found the meteorite came from beyond Jupiter's orbit, and wasn't just any space rock. It was a carbonaceous chondrite, one of the solar system's most primitive rock types, likely formed billions of years ago. They also found another key clue: rhenium. This metal is extremely rare on Earth, but relatively common in meteorites. In the impact layer's rocks, scientists detected trace amounts of it. This all but confirms this visitor from space really came from outer space, not a volcano or a comet. In 2016, scientists announced a groundbreaking result. At the Chicxulub crater, they launched a drilling project. The team successfully drilled over 4,200 feet beneath the seafloor, collecting precious core samples. Those cores contained the original granite bedrock shattered by the impact. These rocks were not only heavily fractured, but severely displaced, piled directly atop sedimentary layers. This further confirmed the theory of a central peak ring formation. Speaking of the peak ring, it's a ring of mountains around the crater's center, like a rebound ridge from the impact. We've only seen this structure in massive craters on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved example. NASA's lunar missions also offered new insights. In the Moon's Oriental Basin, the peak ring formation mechanism matches Chicxulub perfectly. Scientists are especially focused on this structure because they want to validate impact models and see if the area could have been one of the first microbial habitats after the extinction event. Within minutes of the impact, deep granite flowed like liquid, forming a central tower over 6 miles high. It then collapsed rapidly, eventually becoming the peak ring we see today. A layer of molten rock and salt blocks later covered it. Then, tsunamis swept massive sandy sediments into the crater. Also in 2016, during drilling, scientists found a 3-foot-long core containing granite fragments and heat-filled minerals. This means they reached the peak ring structure. A University of Texas geologist noted they long predicted this ring would be a massive hydrothermal system. Drilling confirmed it. Ultimately, the team drilled to 4,380 feet, collecting well-preserved core samples and vast data from the end of the Cretaceous. They also completed borehole scans. Now, scientists worldwide will spend years analyzing these findings, trying to answer mind-blowing questions. Where did the giant meteorite come from? What exactly did it change? Behind the dinosaur's extinction, was it coincidence or a twist of fate?